In the last video, we went over growth and decay problems, and in this video, what we're going to do is talk about compound interest, so financial problems. So compound interest. Okay, so the general formula for compound interest is, once again, it's very similar to the growth and decay problems, but there's a slight difference. So AF stands for the final amount, AI stands for the initial amount, and it's going to be 1 plus R over N to the power of NT. So AF is final, AI is initial, so that's known. R here is the annual interest rate. Interest rate. So in other words, they'll say, you know, the bank pays out, say, 3% per year. N is the number of compounding periods per year. I'll explain what that means in a second. Compounding periods per year. And what that means is that even though the bank will pay you an annual interest rate, say, of 2%, they don't just pay it out at the end of the year. They'll pay it out, they'll sort of take that percentage and divide it by whatever number of compounding periods per year. So if they say they pay out monthly, then N would be 12. So we'll go over an example of that in just a minute. And T is the number of years. Okay, so we got R, we got N, and then we got here's N times T. So T is the number of years. So let's do that. So let's write. So what I'm going to do is just write a statement. And from this we will infer what R is and what N is. Okay. So say, for example, if I say 5% annually compounded yearly. Right? So since it's 5%, R would be 0.05, and since it's only compounded once a year, so because it's compounded yearly, N would be 1. Okay. So let's just say the same situation. So 5%. Again, annually, I'm just going to write 5% annum, which will mean per year, and say compounded, say, what if I said quarterly? So if I said quarterly, so again, this is 0.05, and there are 4 quarters in a year, so N would be 4. Okay, not 3. I think some people might just, for some reason, they would think 3, but there are 4 quarters per year, so it's compounded 4 times a year, so N is equal to 4. You know, another example would be 5% per annum, in other words, per year, right? And we say, I'm not going to write compounded, but say compounded, say monthly. Monthly. So once again, this is 0.05, and N would be 12, right? So I think you sort of get the gist of it, and so let's just move right into a problem. So say, for example, there's a person called Anna, okay, and she has $1,000, okay, she has $1,000, and there's an interest-bearing account that gives 4% per year, right, but it's compounded monthly. It's compounded monthly. Okay. So my first question is, how much will she have in her account? So how much will she have in her account after 3 years if she doesn't do anything with it? Okay. So basically we can just go and plug in our equation. So it's AF, so that's what we want to find out, the final amount. We know that, I'll just write the equation just for the sake of it. So 1 plus R over N to the power of NT, right? So the initial amount is $1,000, and it's 1 plus, the rate is 4%, so that's 0.04. It's compounded monthly, so N would be 12, right? N is 12, sorry, and it's multiplied by 3 because 3 stands for the number of years. So if we plug that in, we get $1,127.27. Right? So that's how much you would get after 3 years. Part B of this question would be, it's really just simple, but how much interest did she make? You know, how much interest did she make? So the amount of interest is just really the final amount, right, minus the initial amount, right? So because the difference is how much the bank is paying her. So her final amount is 1127.27. She initially put in $1,000. So really, the amount of interest she made is $127.27 after 3 years. All right, so I think that pretty much covers that. In the next video, I will cover what the natural log, or sorry, not the natural, but the natural number e is. So stay tuned, and I'll see you in the next video.